Okay, thank you, Puan Rosnia. So your pronunciation is actually quite good on the Achtung. So yeah, Achtung is actually warning in English, or yeah, perhatian in bahasa kan. So yeah, Achtung, your code is think. Okay, today we'll talk about, first of all, we'll try to go through our my journey while I were in the Germany. And then I will talk about my experience a little bit on software architecture at a big company called Kistes AG. And then last would be my experience at Embol Technology GmbH. So Embol Technology GmbH is a startup company that focuses on the code quality analysis. Okay, so yeah, from the flag, from the logo, I think you will know what exactly I want to talk about. So this is my journey. I started my study at the UTM from the degree until master, and then Alhamdulillah got into opportunity from UTM to be one of the young lecturer there, and then I got opportunity as well to further my study at AWTH Aachen University. I joined the group under Prof. Dr. Horst Lichter. So he is a head of software construction research group. Okay, so AWTH Aachen actually in the West Germany. So some of my friends actually here, Dr. Adham, Prof. Wan Nasir, and then Kak Shahliza as well. And then yeah, a few people from UTM School of Computing has been there, Alhamdulillah, when I was there. So I work as a research assistant at AWTH Aachen University since 2012. And then after that, when my contract ended at the AWTH Aachen University, I continue as a solution engineer, code quality researcher at Embol Technology. And then when the pandemic hit in end of 2019, and the company closed because of the revenue shrink very sharply, and then they need to close the R&D group, including me and my boss and few other ex-colleagues. And then yeah, we need to have an option. I mean, to go to India or just stay there. Quit from the company. So I opt to quit the company because I don't want to travel and moving to the India, because this Embol company actually have a lot of offices. I mean, they have branches in Japan, in India for engineering office, UK, US, and Europe as well. And then I back for good since December 2020, because when the company expelled me from the job, and then I don't get any further contract, and then the immigration office say that if you don't have any further contract while in the pandemic, you need to going back to Malaysia, or as quickly as possible you got opportunity in the Europe. But at the end, I don't have any chance to get any job in the pandemic, and then I back for good since last year. And then Alhamdulillah, I got the opportunity to work at Iman Media Group. So Iman Media Group actually is a publishing company, very near to my house right now, just 2 kilometers from my house right now. I can see from here the office exactly from my window view. So Alhamdulillah, I got it. And then I appointed as a head of technology at Iman Media. So the job actually is not quite easy, because I become as a manager, and then I have to manage 5 IT staff. Yeah, exactly, from the different background, the programmer, the data analyst, web developer, and IT support executive, something like that. So yeah, well, Alhamdulillah, because of what we call e-commerce sales 11/11. You know that Shafie right now, they have a very what we call a very big sales promotion today, but in our e-commerce, if you go to browser and type imanshop.com, imanshoppe.com, you can find the e-commerce website, and then you can have 11 promotion right there. Okay, so we sell all the books, type of books, and you can get the fiction, non-fiction, motivation, etc. Okay, so done of my journey. And then I will go through into the case. So while I will be a research assistant at the Achtung University, actually, I have been transferred to this Kistes AG. So Kistes AG actually engineering firm that focus on the sustainable environment management. So actually in the they have engineering and software division. So I have been joined into this software division because they focus on the software development, of course. So the Kistes actually have been established since 1935, something like that, and they have developed their own machine, small embedded system, and a big software right now, until today right now. So they are a really big company in Aachen or in Europe as well. And if we talk about the software itself, the software or the software product itself has more than 1 million line. Of course, it's quite big. If you can imagine something like Boeing system, maybe the size of this Kistes product actually more than a Boeing system itself. So it's quite big. It's a very big system because it has a lot of software product that cover a specific business unit. For example, like business unit focus on the water management, air management, and energy management. So they have a lot of things. Okay, so when I went there, actually I worked with the architecture team. So you can imagine if you have a lot of software product, actually the main people, I mean the main strategic people actually the architecture team, because they need to oversee the overall software. Okay, so if you talk about a big or a messy software product, so it has a sub software product underneath. Okay, so in order to make sure that they align each other, I mean in terms of data streams, in terms of API communication, in terms of data warehouse, something like that. So they need to have a good architecture team. So I joined with them, and almost bi-weekly we have a meeting. Okay, so what we did actually, we conduct a workshop, because when the software become complex, you really cannot theme. I mean, you tak boleh nak jinak kan, ataupun tak boleh nak tengok as simple as one screen, because it's a lot of files, a lot of directory, a lot of data. I mean, boleh imagine software yang measure every seconds, because they one of the machine or one of the software product measure the rise level of water. Okay, so every second actually have a value of generate from the software. So they need to capture all this data and put into their data warehouse or database. Okay, put in simple way. So because of that, because of they have a lot of customer, and they need also to somehow customize their software development based on specific customer. Of course, they need to oversee overall. Okay, so in order to tame the complexity of the software, they need to conduct the workshop, of course, to understand the architecture. And after they understand the architecture, they really need to somehow to measure. Okay, measure the complexity or try to detect any structural issue in the architecture. So my job actually try to make them understand what actually the architecture. Okay, Actually, they don't really have the architecture design from the very beginning, because what they really know, actually, they just have the requirement and then they code. They have the requirement and they code. Yeah, I think most of the software engineer or programming, something like that. Okay, but in the big company, when you just I mean, because of the software development project is quite long, actually you cannot say that, okay, we can start right now from the scratch and then we can develop until the end. No, this is the what we call the software from the early 1980s or 1990s, or what we call a legacy system. So one thing is, in order to modernize the software, actually, we need to understand the architecture, because we really want the essence or the workflow from the software into the new software, isn't it? So to understand the architecture, I need to crawl everything, their documentation, their source code, and try to pass all the source code in order to get the visual design of the architecture. So what I did is, I tried to read all their developer handbook. So they have their own developer handbook. What I mean by developer handbook? So developer handbook, actually the design rule of the system development in terms of the class, how you want to define the module, how do you want to define or design the database, all in the developer handbook. So if you're a new developer or software engineer, first thing first, you need to read the developer handbook, so in order to start your code, if you work with the Kistas, okay? And then from there, you can start. But of course, if you are a beginner, maybe you have what we call a sandbox before you can commit with the real repository, code repository, okay? So get back to the my job, actually. So I read all the developer handbooks, try to understand everything, try to visual, try to make a meeting with several people that really own their codes. Okay, so in Kistas, actually they have people that own the code. I mean, maybe because of he mastered the design concept, the code itself, he know exactly which file connected with other file, or which class actually doing this some functionality as well. So I contact with them, or I communicate with them. So what exactly class doing with other classes? So what exactly a class doing with this kind of database? So I need to understand overall. So and then I try to visual with my conceptual view, with a circle, and then with the arrow, and then with the circle. So I just put all this view and then put into my one large canvas, something like that, and then try to communicate with and discuss with them bi-weekly. Okay. So yeah, some of them will agree, some of them will not agree, because of course different people have different perception with your code, but somehow we need to have the consensus. Okay, this is the architecture that we agree. So actually try to find what are the best way to document this architecture. So I found that reference architecture would be relevant with them. First thing first, because reference architecture have three views, something like that. What I remember. So they have the technical view, and then they have a technical application view, and the other would be I don't remember, but they have three views. Okay. So this reference architecture actually try to help them in order to understand the architecture. So why? Because maybe some other business unit or developer from other business will try to refer from this architecture in order to maybe to connect or to sync with some of the data with their product or something like that. Okay. So from there, after we understand the architecture, so we try to highlight the pain point. Okay. So of course, there are a lot of pain point. Every day, I try to discuss with them. They always comment or critique or maybe say some bullshit of the architecture, because yeah, because of the complexity, because of too many difficulties to understand. At the end, you need to define the set of rules in order to make sure that you have the what we call the structural integrity between the module, between the layers, or between the communication as well. So we need to define all the things, okay? And then from there, after we highlight the pain point and try to design what are the best way in order to reflect this thing, either in a short term or very long term strategy. So okay, this something like that. So we have the meeting, and then we try to visualize the class or the package or the model element. So what we see here, actually, this is the real whiteboard that I discussed with them. So in the center, actually, are the server. So DC server module. So this DC server module actually is a component, a lot of component, a big component that communicate with other component as well. So yeah, at this time we are, yeah, of course, really using the UML concept. Okay, so don't skip the UML class, of course. Okay, design still relevant until now, of course. And this is the way you can communicate with other developer and programmers. So in Europe or in Germany especially, if you are master in the UML design, in the very basic, and you know what to represent the communication between the element, I mean the classes, module, or package, something like that, with the relationship in the UML knowledge, I think they will be good. They will understand, and you know that you know that how this software function in every part of the software. Okay, using this UML, some sort of design. Okay. Yeah, this is what we call the reference architecture. I forgot to put the citation on the source. So actually, this reference architecture documentation come from the German people. So I thought I want to find other documentation at that time, but I think when I said to them, okay, this is documentation from the German people, you should follow. Okay, they agreed. So I don't have any. I think I don't have any comment from them because they know this reference from the German people. So yeah, they agree. So dia, masalah lah kan. So they tawar from other people. So kalau mungkin from other region, from other people, so there may be some suspicion lah, mana datang documentation ni kan. So when I thought, okay, this is our reference architecture, I follow this kind of model, A architecture, and then we have a technical architecture, and then we have technical infrastructure architecture. From there, we can see the overall architecture design for the business idea software. So yeah, as I said before, when we have the real UML design, component communicate with other component, you have your direct communication with other component, and then from there you can detect the structural issue in the architecture. Okay, so it based on the rules that you defined before. I mean, if you design your architecture based on layer, and maybe you have a top, middle, and bottom a layer, and then you try to define some sort of rule. For example, that a middle layer cannot directly communicate with the bottom layer. Okay, so you know that that's the rule. So when you use the architecture analyzer tool, for example, like SonarGraph Explorer, and you pass your source code, and then from there you can see that is it the layer can communicate with bottom layer or not. If yes, and then it detect as a architectural or structural issue lah on the architecture. Okay, so this is the example. I try to from my side, I want to understand what exactly the DC server or the TSM system. So TSM system is time series management system. So this is the core of the software product of the Kistes product. So they use time series data as a main component in order to get all the data lah from the device that I said before. So the device measure the rise of the level of water, and then they get the value, and this value will transfer to other component, and they have their own analyzer, they have their own parsing, they have their own what we call visualization. So and then come together as a complete software product. So I try come up with the conceptual model to understand the big complexity software, and then from there I create some of the arrow in order to understand. So what component describe what, and then what server communicate with what server, and it really helpful from my point of view. And other architect member also say that this is very helpful for the very beginner, and it really helped me in order to document this thing into the reference document. And then when we use software, I mean the architecture analyzer tool, as I said before, Sonograph Explorer, I need to do some mapping. Why? Because the software, the Sonograph actually doesn't know what kind of element inside your software product. Okay, I mean in terms of class, package. In this case, bundle, because they use OSGI framework or technology to develop their software product. So I need to have a big picture. So what are elements inside this software product? So they start from the class instead of package instead of bundle instead of composite bundle, which have a client and server interface, and maybe part of them are metadata. And this composite bundle actually is an application bundle. So a lot of bundle or component inside this thing. And in order to run, of course, you need to have this kind of framework or SGI implementation. So I put this into my what we call model to me to understand before I do some mapping. And this is some Sonograph architecture element. Okay, so yeah, bila you nak buat mapping, you mesti tahu kan dia punya character A, character B, because you want to do some mapping. So you need to really have the element of A and element of B before you can do some real transformation, real mapping lah, before you can sketch out ataupun design lah dekat Sonograph Explorer tu. So in the Sonograph Explorer, so we have the system, we have the project, and then from the project we can compose into the logical element, and logical element actually consists of dependency, assignment pattern, interface, system layer. And then from there baru kita tahu macam mana how to do the sum mapping. And bila when we know how to map, and exactly we know what are package, what are bundle, what are system exactly visual in the Sonograph architecture element. And so from there baru kita can detect the structural issues on there. So it is very easy because when we crawl the code base, and the Sonograph Explorer will visual something like this. Apa yang kita nampak ni actually some sort of directory, and in the TSMQ server you have different type of components, and the TM server, a lot of things inside there. This is a very big system. So when we define, as I said before, a set of rules, I mean your component cannot access the other component, and bila kita dah siap define rule tu, and then from there bila kita crawl ya ataupun run the Sonograph Explorer, we know lah the red line actually is the violation lah. So very easy, and we know that from there lah what is the which component ataupun which bundle exactly has more interest, I mean has a hotspot, I mean in terms of dependency lah kan. Maybe some of the component have a cyclic dependency, or maybe some component has very attention focus on that, so maybe it has a big class or big component on there, so maybe something wrong on there. So from there we can dig down lah why actually the component has a big chunk of functionality inside of the big software product. Okay, this is what I call architecture violation. So from there we can see that this component has access to the TSM server station, and how many have this kind of dependency, and 53. So one nice thing regarding the Sonaga Explorer, actually you can detect the violation issue ataupun structure issue, and then from there you can click and you can see the which component related on that and which class have dependency on that. So it's very powerful architecture software architecture analyzer tool untuk kita analyze dan monitor our software architect. Okay, and then this thing is useful lah sangat for business decision maker ataupun top management because they really want to know what's behind that. Kan? So on the top management, they really want to see the monetary value lah. Of course, kalau we have these things violation, so how can we translate into the money? Kan? So from there we can estimate how much refactoring costs, how much we want to fix this. So which one we really want to fix first, or which violation has a big risk on that. So from this architecture dashboard, so it's very useful for the lead developer or top management if you really want to modernize the legacy system, or to modernize the existing software product. Okay, so this is my experience in the case test, where I really interested in the architecture analysis, and from there actually I developed my capabilities on analyzing the software design lah, based on the software metrics. And then after, at the end of my contract in the university at AVTH, so I got a call from one of the founder startup company called Embol. Before this, the company called as Gamma, and then they changed the name. So you can try the code quality analyzer tool at embol.io. If you type right now embol, EMBOLD.io, so they have a free subscription package in order you can analyze your code not more than 1 million line of code, I think, or not more than 100,000 line of code. Yeah, so it gives some powerful indicator that you know that which part have really problem, and then how many issues on your code base. Okay, so because of my experience there, I got a call, maybe because of my LinkedIn visibility when I tried to update at the end of my semester there at the university. I got call and they said they really want to have a researcher that focus on the parser. I mean the code detector, the code. We call the code analysis detector. And then they say that they have applied some AI or machine learning part on their engine in order to be more what we call give some a good smelly class candidates before we refactoring. So I said, yeah, I can join them. And then, alhamdulillah, I moved from Aachen in the West Germany to the Frankfurt, which were a big city, or we call a European financial city. Yeah, from this company, actually, I really drill my skill on this, not just focus on the code quality, but into my technical skill. I mean, if you have a very big developer teams and you have your DevOps server, I mean from your staging your code until your production server, so you have a very big server, I mean you have a big company, and then how you want to make sure that the code after you deploy have a very good quality from the staging, from the commit until production code. Okay, so I worked there as a solution engineer, and then first thing first, what I did is actually have a talk with their engineer. So they presented what they have. I mean their rule engines, because in order to detect the code smell or any code issues in your code base, actually you need to have the engine, the rules. Okay, so the rules, so they present the rules, and then I said that, okay, a few things that we can improve based on a specific language, I said to them, and then I proposed something to them based on the scripting language. I mean focus on the TypeScript, JavaScript, that's too. So I told to them that the rules for the object-oriented smell not equal with the scripting language. Okay, because in the object-oriented language, you treat the software element, for example, like class, product, a class, package, or maybe methods, something like that. But in the scripting language, for example, like JavaScript, you treat them as a file, and or a big chunk of if else, something like that. So you need to have a different perspective. So they agreed, and then we from there have a different few discussion on that in order to improve the detector for the scripting language. Okay, to give some overview on the code quality analyzer. So I think some of you have some experience using this kind of code quality analyzer. So it depends on what role you are. I mean, if you are a developer, maybe you use code static analysis tool in a very light way. I mean, while you are working on code, and then your IDE, I mean your working environment, for example, like Eclipse, or like lagi satu tu, dah lupa dah. Yeah, selalu guna Eclipse dulu, and then maybe maybe some warnings dekat bahagian bawah tu kan will display, okay, this code in the line something have violate something. Okay, so it depends on the views. Kalau you developer, you can maybe have like simple code analyzer lah. But if you really go into next further stage, maybe code quality manager, some of the company have this kind of roles, or maybe code quality gater, ataupun yang jaga gate sebelum production code. They need to have a good procedure and a good tool in order to catch any code issues or code smell lah. Okay, so some of you maybe doesn't have idea what is code smell kan. Oh, code pun boleh bau code pun boleh ada isu So of course, any code yang you nampak macam pelik, I mean in term of communication between class, ataupun dalam class tu sendirian, between methods, ataupun something like the if else, very easy lah. If else tu very long. I mean the nested if else to very long, maybe more than 3 if else. So actually in terms of a good what we call a good code, actually is dah violate lah. Tapi it depend on the how you design the software. But in most cases, ataupun dalam dunia akademia ataupun dalam dunia research, if you go beyond, for example, like cycle complexity kan, more than 3 or more than 4, it's become red atau it become warning to your indicator lah dalam code quality analyzer tu. Okay, it depend lah. So if you have a code quality analyzer tool in front of you, and then you can see that this tool actually examine and parse the codes, and then it gives the warning, and you know that this one actually refer to the smelly class ataupun smelly package. So it depends on the tool. Actually, you define the element that you want to see. And then from there, you can report to the developer or to the fixer and then said, okay, you need to fix this because of this. Or maybe there is a likelihood become bugness ataupun error proneness, something like that kan. So you need to report that, but it depends lah macam mana how you design your software development workflow. Okay, by the end the software quality code quality analyzer tool actually to catch any of the suspicious code ataupun very low quality code inside your code base. Okay, and then so ini yang dia punya internal lah. I mean, if you have some source code, so code static analysis ataupun code quality analysis actually scan your ataupun pass your code, and then ada dia punya laser kan, dia akan scan lah kita punya all the words inside the code as a lexer dengan token dia, and then dia akan cuba pass into the abstract syntax tree. And then from there, if you have some specific metric that have defined before, and then they will compare, and then from there it will calculate lah the matrix number, and it will indicate lah at the end as a result lah. And then from there you can tell lah your code actually how is it look like lah. Is it a good software or is it a bad software, something like that. But somehow in real software development actually dia tak ada setiap masa tu you have a good code. No, exactly, they will improve by time, but it depends because bila you develop ataupun write the code, actually dia akan menambahkan line of code, of course kan. So the complexity of course going increase. By the end yang paling utama adalah yang orang paling hujung tu, yang nak refactor tu. I mean mungkin developer sendiri ataupun the other person yang nak mencantikkan numbers in the code quality analyzer tu lah. But dia punya progress is very little and very low, but it depends how you manage your software development workflow. So inside this DevOps server actually, so we install this Gamma ataupun Embed, Gamma tu nama dulu, into their continuous integration server. So from there lah, whoever ataupun which file commit into this server, and then it will run automatically lah by Gamma ni, and then it will represent the result of the quality into the developer ataupun manager, and then from there you can fix based on the priority lah. Okay, this is the example. What you see actually the dashboard, not the dashboard, actually the project overview of the Gamma. So from this you can see that this is all the open source software. So you can see the Apache 1.9, 2.6 million line of code, and then ada 5 database, and then this Apache have consists of Java and C++ language. So 1.9, what does it mean? So kalau guna Gamma punya tools ni, 0 is very bad and 5 is very good. So 1.9 actually is in the middle lah. I mean you will get warning yellow ataupun yellow punya indicator lah. So if we go into the something like Apple ataupun Ethereum ni kan, so nampak green kan, so it mean that is I think Apple ni bukan Apple handphone ataupun software, I think it's another open source software kan. So seem like very good, but of course not a perfect one. But also, of course, it depends on how you define the rules ataupun metrics inside this kind of software. Okay, this is very interesting lah for lead developer ataupun developer itself lah, because we can see the hotspot inside there. So what does it mean by rate? Actually, rate is you have really high issue on there lah. I mean, numbers of issue is quite strong there. Maybe in terms of complexity, maybe in terms of encapsulation, maybe in terms of line of code, maybe in terms of what. So from there you can go into the rate spot first, and then it will show the file, and then you can directly dig down and try to fix which part of the code actually have very potential to be a bug or error. Okay, so this is the dashboard. So right now we have 1.36. I mean in the middle, not so good, not so bad. It's open source called Kafka Java. So Kafka, I think the machine learning punya open source tu. And then we can see the graph. Actually, this is the indicator of the the grade lah. Somehow dia yang bagus, kadang-kadang dia turun. Somehow, sometimes dia naik. So this based on the commit lah, ataupun based on version. So if you have a lot of version of the software, it will crawl every version tu, the version number tu, and then you can see lah how your code actually improving over time. Is it going down or going up? And from there, this also another information: total line of code, component, and hotspot. Okay, total line of code have 3075, so not so quite big. I mean, it's easy lah kita nak study kan on the open source software. And then have 21 components. So component ni pun terlalu fragile punya definition, but it depend how you define lah component tu dalam Java ni ataupun dalam Kafka ni. And then hotspot means you really want to see what kind of hotspot inside this one. And then they present this code quality based on these 4 pillar lah. Design, it depend on the object-oriented or script language punya indicator ataupun rules. And then metrics, it depend on this lah, DOIH, number of methods, complexity, request per class, and then coupling between objects, something like that. Okay, so I think ini mudah je. And then duplication, dia pun ada powerful engine lah untuk compare ataupun nak identify duplicated code lah. And then of course the code issues lah. Code issue ni pun based on criteria yang kita akan set daripada awal lagi lah. Mungkin some of them not really straight, some of them may be very loose, but it depend. Sebab code issue ni terlalu banyak, it depend. Sebab kadang-kadang dalam automation, they really have I think more than 1000 code rules yang dia perlu dipatuhi, because you play with the small part and the embedded systems, something like a very crucial and real-time system kan. And it depend lah. Kalau based on European punya code quality, dia bagikan kepada 3 lah, yang betul-betul critical, yang medium, and then yang very low lah, and it depend. This also quite useful lah for refactor ataupun software maintainer. Dia nak tengok kan dependency between the classes. If you crawl, and then it will try to connect with all the classes or methods, and then from there we will know lah this class actually has a transitive dependency with other classes. So this is very nice lah way lah kalau kita nak tengok kan. So if you look there, single request test have a lot of dependency with other classes. So if green, it means that the class is a good code, and kalau yellow tu maybe something wrong. But at the end, selalu yang saya tengok, I will go to the red first. Kalau tak ada, I will go to the yellow first, and then from there we'll drill down lah which part of the code has a lot of issues. Okay. And also this one is very useful for software maintenance auto refactoring, because it will bagi powerful recommendation based on your class ataupun modules. Sometimes we don't know exactly how to refactor based on the partition of the module. But at the end, this I actually use the relationship atau dependency punya classes and the name of the class that maybe have some potential to be partitioned into one big chunk of module lah. So it depends. So we can play with that. Okay, nak dia punya granularity dia nak bagi tu besar ke kecil kan? It depends how we want to make it the size of the module. This one is a nice one juga untuk code quality analyzer from the MBOL, because it gives some recommendation which could actually have the likelihood to have a bug in the future. How? Because the engine actually try to analyze the commit on every classes, and then maybe some reported issue lah from the bug reported issue. Because kalau ikut on real software development, you have your issue tracking system kan, like Jira or Bugzilla or whatever, and then you have your Git version ataupun Git repository kan, contoh macam GitHub ke whatever lah berkaitan dengan Git. So from there it will analyze and give some hint. Okay, this is code actually have several frequent time have been changed and have been reported many times in the issue tracking. So somehow maybe in the future this code actually like have a maybe high likelihood to be error or issue prone in the future kan. So it's a powerful code quality. And one thing yang I work as a solution engineer there, actually I also try to find ni nak habis lah, don't worry. Ada competitor punya kelemahan lah. That's how the market actually work lah. I mean, if you want to be strong, you need to find your uniqueness. I mean, you punya blue ocean tu in order to be on top lah. Of course, there are a lot of code quality analysis tool out there in the market, but to be in the top, to be established in the red ocean, to be the ocean blue punya product, you need to study lah. So I study Sonaco, I study SIG punya analysis tool, I study Coverity, I study every code quality analysis tool in the world ni saya study lah, and then just present to the CEO and CEO say okay, our product actually not bad. But of course itu yang kerja merenyah kan, but at the end itu ya kerja researcher kan. You need to dig down all the information data and then try to give the real fact to the stakeholder lah. Okay, so untuk menutup for my conclusion actually, to be special actually in certain field actually is out there. I mean ada je di mana-mana kan. I mean you can be expert on one thing and then go there lah. I mean to find the specific company ataupun specific interest yang kata apa ada kat tempat tu, actually is very hard, but at the end it depend how you visible yourself lah. So by the end nak ceritakan ada code quality ni banyak kat dunia ni. There are a lot of code quality analysis tool and they already support on the both qualitative and quantitative lah. So jumpa nak cerita. So qualitative dia akan measure maintainability, readability or what else kind of software quality attribute out there. You can do it with the tools. By the end quantitative is also I think a lot of tools cover there. But somehow bila kita guna different tools to measure same code, actually we will get the different result. That's kadang peningkan saya juga lah. By the end I will focus on one specific tool and then I believe that the tool will help me on improving the software. And then of course the code smell or code issue actually will reside forever in the code. Dia takkan hilang, dia akan sentiasa ada. Buat macam mana pun, if you fix the code, try to remove the smelly code or smelly class, actually it will remain forever. So because of what? Because we cannot catch everything lah. Of course dengan tool pun actually dia terlepas juga, but because we always focus on what is the most important one to refactor ataupun to fix first kan. And then last one is satu je yang saya selalu cakaplah dengan member kan, kalau tak ada masalah, if you don't have any issues, don't fix it kan. Ya, kita tahu dalam code tu ada smell code atau smell ada issues, but if they don't disrupt our process, our software development workflow, don't fix it. But of course it depend on the specific condition lah kan. But if boss really want to fix the code because of this thing actually make it more money, then we need to refactor lah. Okay, I think that's all for today. I'm sorry because I yang paling banyak bercakap kan, so maybe some of you have different ideas and maybe some of you have a question.
Assalamualaikum.
Waalaikumsalam.
Okay, Firdaus, Mr. Firdaus.
Yes, yeah.
Can you explain, is it necessary to do the code or design refactoring if if the software have if the software score a very good score in software health lah. Is it necessary to do the design or code refactoring?
Refactoring for a good design. Okay, I think it depends on the request lah. Maybe it doesn't mean that refactoring to improve the maintainability or other software quality. But maybe some of the refactoring actually to improve the readability. Of course, it may not violate any rules ataupun any quality attribute, but in the end, it's really hard to understand, for example. So maybe, yeah, you need to refactor. So the answer is it depends what kind of request or any or issues that you plan to refactor.
Assalamualaikum,
Salam.
Mr. Firdaus. Long time no
Adib.
see. Long
Adib
time
dah
no
sedia
see.
jumpa kat dalam.
Itulah. Nampak dah apa tu semakin handsome. Okay, anyway, I have this question in apa tu because it's not easy and not every company has opportunity to do clean code and code refactoring and so on and so forth due to the cost and so on. So cost is one thing, another thing is competency of the staff. So what do you advise for a startup, for example, or maybe 3 years, 4 years company, for them to be able to have also a clean code? Because I believe in our team also we have this problem because as you mentioned, this is very important if you want to maintain the code or want to upgrade later on, or you want to share the code, co-develop and so on. So it's very important, this clean code. So but the problem is the competency is not easy. You cannot have like 3 years experienced developer that can do this kind of things. So what do you suggest in this situation, in this case? Thank
Okay.
you. Keep in touch.
Thank you, Adib. So my suggestion is, I would say, two points. First thing first is about the culture. So we can start from the what we call a good code practice. Okay, so what is a good code practice? Actually, in a company, I mean, as a specific in Europe, they have their own code standard practice that they documented in Wiki or in their PDF, something like that. So this code standard practice will document all necessary design or all good quality design of code into one PDF. So it means that the new staff or beginner, we start this first before going deep into the real code. Okay, that one, it will be the culture. And second would be kalau tak nak go to culture, you can just install any type of library in terms of the code rules or code standard rules based on type of languages into your IDE. And so something like I think Eclipse, they also have this kind of plugin. We just install the plugin, and there's this kind of code rule for example Java, and then when you try to write, and then automatically it will highlight the warning or the red flag into specific part of the code. There will be second suggestion. I think it's a good start, but at the end, it takes times to understand, to develop the culture, and from there maybe it will remain as a value lah dalam company tu kalau dah culture to the start on the basic code level. That's all.
Thank you, Firdaus. Tapi ada satu lagi tambahan sikit je. In your opinion, dekat Malaysia ni, how much or what is the percentage that the companies in Malaysia, software house and solution provider and so on, how many percent the company is practicing this type of clean code? Sorry, tambahan.
Okay. Honestly, I don't have any fact ataupun information on that lah. I'm so sorry. I tak pernah terjumpa, terserempak ataupun tersembang on this topic, but I believe ada. But maybe still remain mystery in the company, or maybe or maybe somehow maybe the lead developer ataupun senior developer just don't want to expose this thing lah. But I think yeah, we can start this kind of culture or this kind of topic into small or startup company in Malaysia.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh, Firdaus.
Masya Allah, Dr. Dayang.
Okay, I have a question because when we're talking about software engineering, it's the same with other engineering discipline. We are embedding the culture into the new software engineer. Okay, and then one point that from your point of view, how actually because when we embed the discipline of the software engineering in our students, definitely that when we design, we will get input from not enough because just like some sort of foundation, right? We cannot really put everything so that they are ready to start.
Sorry, Doctor.
How can you see the collaboration that we can do, especially in Malaysia? Can you hear me, Firdaus? Yeah. Hello.
Okay, right now I'm clear. Tadi terputus-putus tadi.
Okay. All right. Sorry, because I'm in Sarawak now. I'm on leave.
Oh.
Okay. How can from your point of view, how does this Malaysian contact between industry and academia can work together in order to produce a ready future software engineer for our Malaysian industry?
Okay, thanks, Dr. Dayang. Dr. Dayang tahu what is the real hard question to give to me. So I think it would be from the class. I mean, from the programming class. I mean, all the lecturers. I mean, I believe that a software engineering lecturer in the School of Computing UTM have this kind of capabilities. I mean, in terms of code quality analysis. So we can embed this kind of skills of code quality analysis in our class. I mean, even with small task or assignment with programming, maybe we could try to use any open source code quality analyzer tool to at least to get some exposure on that. And then from there, we can continue to the maybe final year project, and let's see how your code quality for your final year project. And then we can try to nurture this skill in maybe from the final year project into the internship area. I mean, so it would be I think the start to start with the small assignment with the code quality analyzer tool, and then going into the final year project with I mean we report all this kind code quality tool result into our final year project, and then from there he or she has get some experience, and then try to use or apply in the industry, and then from there we will see how the industry react with our initiative. That's all from my side.
Thank you. Terima kasih, Firdaus.
Now, I would like to invite Mr. Luqman to deliver his research progress presentation.
Our research title is Combinatorial-Based Test Data Generation and Cost-Cognizant Approach for Model-Based Test Generation and Prioritization. So this is the structure of my thesis draft. I have six chapters. So we'll go through all this one by one later on. And so for each chapter, I will do this list. So first, I will show the examiner's major comments. So note that major comments. So there are minor comments. So those minors I did not include in here. So I want to make it shorter, so just include major one. And then I will also list the new progress that I did since the first progress presentation. So for the first chapter, the introduction, not major comment by the examiners. And the new progress that I did for this chapter is I added more scopes of study. And this is the subsections for my chapter 1 introduction. So we have 7 subsections. We have the typical ones, overview, problem backgrounds, segment, objective, and so on. We'll go into some of them. So this is the overview. So I will not go into this because I already explained this in the first progress, so nothing has changed. So we'll skip this one because we have a lot more to cover in the literature review, so I need to go a little bit fast. And problem background, we also skip this one because I will explain this more in more detail in my literature review, the problem background. This is also the same with my first presentation. This is the problem statement. So I can skip this one. So I will recap the research objectives so all of you can get the main idea what my research is about for those that have not watched my first presentation. So the first objective of my research is to propose an automated test data generation approach in this means the model-based test case generation. Okay, so an approach that. And then second objective is to propose a cost-cognizant. So other meaning is cost-aware model-based test case prioritization approach that address different test case costs. And the last objective is I want to evaluate the effectiveness and efficiency of the both of my proposed approach using suitable metrics, case study, and benchmark with related existing approach. So those are my objectives. So these are my previous scopes for my first presentation. So these are the latest scope. I added a few more. So I think I skip this one and not necessary. Okay, and these are the contribution. Also same with my first presentation. So I skip this one, and this is the thesis, my thesis outline. Okay, so I will focus more on the literature review because this is where the major comment is from the examiners. So the first comment from the examiner is that I need to include literature review on the integrated works of model-based test generation and prioritization. This means for the integration approach, the approach that combine generation and prioritization. I need to include literature review on those existing studies because the current analysis is not in depth looking at the integrated approach. And the second comment is the review performed on the model-based test case generation and model-based test case prioritization is not comprehensive. For the PhD level, I need to go more in depth into these two fields. And the last one is I need to add comparison tables in literature sections to summarize the reviewed studies. So the new progress will be to address these comments. So this is the previous structure of my literature review chapter. So because there are a lot of changes, so the structure also changed. So I think don't have to explain this one. So you can see here we explain about model-based testing, the model that I use, standard finance estimation. So this is the previous one. So the latest one, so I changed a bit. The first two is the same. The third one I review about combinatorial testing, and then so on. And I will go into detail to the others later. Okay, so this here I give some brief description about model-based testing. So this one is already explained in my first presentation, so I will skip this one. So you can watch my previous presentation if you want to see my explanation about this. And this is also has been explained previously about the model that I use in my research, the model that I use to do my proposed approach. Also, I will skip this one. This I will review about combinatorial testing, the technique that I use for my automated test data generation technique. Okay, so I will start to explain from this part. This is the new part that I add based on the comments. So the first one is about the model-based test generation and prioritization. So because this research proposed to approach generation and prioritization, existing studies that propose both approach were identified and reviewed. And the reasons, the justification why the approach combine generation and prioritization were also identified. And in total, there are 7 studies identified that propose the combination approach. And this is the summary table of the existing generation and prioritization studies that I got from my review. This is the first page, and later there will be another page. So for example, here you can see that from Martinez et al. 2018, their motivation to propose the combination is expected to lead to more failure detection within time and resource constraint. And I also review the model used and their motivation. They use Simulink. This is their motivation. Then I review the approach type. So the study used search-based. So search-based is where the tests were generated using SA search algorithm with the objective function to maximize diversity among tests. And then because so this is the combination with generation and prioritization. So the second one is for the prioritization. They use coverage based to prioritize tests. And then I review the evaluation metric used for the generation and the prioritization. So you can see here, these are the metrics that they use to evaluate the approach. And lastly, I review whether they use any evaluation metric to assess the combination approach. So it was identified that not use any metric to assess the combination approach as a whole. So they just evaluate them independently. They evaluate generation and then they evaluate prioritization separately. This is the second page. So in total, there are 7, as I said earlier, this 4, this 3, 7. And this is the remaining one. So I will just go fast to this one. Because later we go to the analysis and discussion of the finding that I get from the comparison earlier. So the first analysis is that only several studies that propose generation and prioritization integration approach were identified. So this proved that there were not many integration approach in the literature. These studies were obtained using, so I made a systematic literature review studies. So these studies were obtained using the SLR process. So if you understand how SLR process works, so you know the process to get the primary studies is very rigorous. So we can say that the chance of overlooking any study was quite small. So a possible reason why less few studies because most researchers focus on them independently. And the second analysis is that all existing integration studies either evaluate the proposed generation and prioritization independently, or only evaluate one of the two, but never both as a whole. As I showed earlier, here in the last column, they never assess the approach both. They only assess independently, or only one of the prioritization or the generation. So this is the discussion. So I think I'm with this one. So because at the discussion earlier, this research was decided we focus on addressing both generation and prioritization independently. Okay, so another reason why we want to propose, why we want to address generation and prioritization independently, because we want the approach to be loosely coupled between each other, so that later the standalone generation and prioritization approach can be utilized easier with other approach, can be integrated easier with other approach in the future. So for that, the literature review continues by continue the review of the existing approaches in the model-based test case generation. This is the review that I've done for the generation. So I review based on their type of approach, model use, evaluation metric use, and their limitation. So firstly, this is a graph showing the number of studies published, number of studies reviewed in this research literature review. So in total, there were 100 studies proposing model-based test case generation that were reviewed in the study. So actually there is quite a lot of paper that I need to read to identify their type of approach, model use, metric, and so on. Okay, so this is overview, and then these are the type of approach. This is also already explained in the my first presentation. Okay, yes, for example, coverage-based, state-based, set-based, many more type of approach for the generation. And then their models used to perform their approach. You can see here we have finite state machine, a standard finite state machine, activity diagram, and so on, many type of model. And then the evaluation metric that they use is also as already presented previously. You can see the most used test suit size, the number of test case in the test suit, and then okay, so the limitation in the existing model-based test case generation. So the most common limitation in the existing studies, in existing generation studies, was the dependency on completeness and accuracy of specification. So this is actually a slightly fundamental limitation, because this are model-based approach. So for sure they will need adequate or complete model to get a good approach. And then second most common limitation was the requires manual generation of inputs, effort, oracles, and test data. And we also have other limitation. And then the review, result, analysis, and discussion. So I analyzed and discussed the findings that I got from the previous earlier, the approach type, model use, and so on. But for this presentation, I will only for the research focus for the second most common limitation. So that is my research focus, so I will focus on that one. So the analysis is that the second most common limitation is selected generation studies was the need for manual input, effort, focus, or test data. Okay, and then these are the discussion. And then, okay, so this research focus only on addressing the second most common issue, specifically the manual test data generation issue, as I already said in my research objective. Okay, so manual test data generation is very costly, difficult, and laborious. So although test data generation is one of the main aspects in model-based testing, apart from test case generation and test script generation, However, it is still one of the major challenge in automating model-based testing. And then a recent study by Ahmad et al. 2019 that reviewed model-based testing study using activity diagram. So they discovered that more than half of the study did not explicitly specify their test data generation method. So this indicates that test data generation in model-based testing was still underestimated despite its importance. So more research is needed to improve the test data generation in model-based testing. So because of that, this review performed a more in-depth analysis regarding the test data generation in existing model-based test case generation studies. So this is the continuation. So here is the analysis of test data generation in existing MB-TCG. Here is the summary table that I did for the review of the existing MB-TCG studies. So for example, we can see here from Kamat et al. 2018, they proposed a study, proposed model-based testing for early testing in the software development life cycle to reduce development costs. And then I identified the test data generation method, which is for this study, they use test data that are provided by the tester. And then I identified the test data generation process, which is provided by the tester, means that it is manually provided. And then here we can also see that most of the test data generation of the studies are manual or semi-automate. And this is the analysis and discussion for the review, the comparison earlier. So the process of TDG, the test data generation, in most of the discussed study was manual. Okay, and then this explains the disadvantages of manual TDG. Another analysis is that most of the discussed studies can still considered as latest, published in the range of last decade. So you can, the studies are still latest, it's not very old. So you can see that manual test data generation was still practiced in recently proposed approach. So these findings motivate this research to improve the test data generation in model-based test generation. However, to propose a good automated TDG, so this research first reviewed the existing automate TDG techniques in the literature. Okay, so first we review the existing techniques in the literature before we want to see what techniques is the best to use in our proposed approach. So this is some explanation about the automatic data generation techniques. So here is the classification of automatic test TDG techniques that I found in my review. I reviewed studies. So this is the classification that I come up with. So we have about five types. We have random based, which randomly select the data from the input domain. Also have symbol execution, dynamic, combinatorial-based, which I used in my proposed approach, and search-based. So these are all the common test data generating techniques. After that, I also compare the advantages and limitation of these 5 techniques. For example, this random based, you can see here that it's suitable for small scale system and obviously cheap method to implement because just randomly select, no need to do any processing, and easy to implement. However, the limitation is coverage issue, testing requirement information are not utilized. And here we can also see the advantages and limitation for other techniques. I'm going to skip this one, and then we will continue for the review for the model-based test case prioritization. So for this one, it's the same with the generation review based on their type of approach, model use, metric, and their limitation. Okay, so first of all, this are the number of studies that I identified, that I selected in this review. In total, there are 15 studies proposing model-based test case prioritization that were selected. So here you can see fewer studies than the generation. And then these are the type of approach for the model-based prioritization, and then the model used by this prioritization approach, then the evaluation metrics that they use. You can see here the most used metric is APFD. So for those that research in prioritization, they will know that APFD is the most popular metric. And then the limitation in the existing model-based TCP studies. So here I made the summary table. You can see here I list the evaluation metric used, and then for the metrics, does that metric address different test case costs? So you can see here that none of the selected studies address different test case costs. Okay, so from that, the analysis and the discussion. So again, this I just present the analysis and discussion for my research focus. And so all the selected MBTCP studies did not address different test case costs. That shown earlier in the last corner of the table. So why cost consideration is important in prioritizing test case? So first reason is that the main objective of prioritization, okay, is when the number of test case is large. So if the test case is small, then prioritization is not very needed. So when the number of test case is large, is to save the testing time by finding fault in shorter time. Okay, so not in lesser test case. Okay, so if lesser test case, the less test case might still need more time to execute. So still not efficient. So we want to save testing time by finding more fault in shorter times. Okay? Then that is why the cost consideration is important. And another reason is that cost consideration makes a huge impact in large scale testing. And then the last reason is, in practice, tests normally don't have same cost associated with them. So we need to consider cost when we prioritize test case. And then from the discussion earlier, it proved that cost consideration is indeed important. So because of that, this research performed a more in-depth analysis on the selected prioritization studies in terms of their cost consideration and the use evaluation metric. So here is the summary table. So for example, you can see here that Mahali et al. 2018, they proposed a prioritization approach to reduce regression testing costs. The evaluation metric is FFD. So the motivation of using the FFD, they stated that to assess the effectiveness and efficiency of the prioritized test suite. However, this metric does not address test case cost. So actually, they did not address the efficiency of. They did not assess the efficiency. Okay, so here we can also see the other. So you can see here that all of them did not address test case cost. Okay. So from that, the analysis and discussion that not a single review MBTCP studies address the test case cost during prioritization. Okay. So cost consideration should not be taken lightly. So as I already explained earlier, the importance. And then so this finding motivated this research to propose an MBTCP approach that take test case cost into consideration when prioritizing test case. So this is, if you remember, is the second research objective of my study. And then before that, to propose an effective approach. So this research first reviewed the existing TCP approach, the existing cost-cognizant TCP approach, which not including the model-based one with cost consideration. So first we need to review those the existing cost-cognizant approach. So here are the summary table of this studies, this cost-cognizant prioritization studies. For example, Chen et al. Said they propose a cost-cognizant approach that predict optimizable TCP approach to reduce regression testing time. So you can see here that all of them want to address for regression testing. And then there is one observation, and then these are the evaluation metric that they use. From here, we can also see that the most used metric was APFDC, the cost-cognizant APFD. And then, of course, this metric, they adjust as cost. And then I identify what are their cost representation. And then the analysis and discussion from that summary is that all of the cost-cognizant TCP approach review focus on improving regression testing. So why they because they focus on regression testing, so they can use the history-based test case prioritization. So history-based prioritization, they normally use test cost, fault identified by test, and severity of identified fault, which are known from the previous iteration of testing. Okay, so they have the information, so they can use them to guide the prioritization for the history-based. But there are also the limitation of the history-based. So these are the assumptions. Another analysis is that, as I said earlier, PLDC was the most used metric in the existing cost-cognizant approach. And lastly, last analysis is that in model-based content, not single MBTCP approach has taken account the varying test case costs. Okay, so this is the reason why the approach to be proposed in this research will be cost-cognizant approach. Okay, so that's for the chapter 2. Okay, so for chapter 3, there are no major comments from the examiner. The new progress is, these are the new progress. I update the research framework, added 2 more case studies. Previously, in the first presentation, I only have 1 case study, and then I add another metric for the generation evaluation, the code coverage metric, and then I also add the metric for the prioritization evaluations, which is the APFDC. So this is the subsection structure for this chapter 3. First one is the operational framework. So I will skip this one because I already explained in my first presentation. So nothing has changed, still the same. And then so I update the research framework. So this is the previous one. So I changed the boundaries, this boundary between conventional generation and the proposed enhancement. Okay, so I already explained this in the first presentation, so I will not go into details. So I want to highlight in the latest research framework that I update the boundaries, that the proposed approach is this part and the conventional is this part. So there's several steps in doing the generation that both share. So this is my proposed approach, this is the conventional approach. Okay, so that is the research framework. And then these are my case studies. So this is from my first presentation, the diff system. And the second case study, this is the newly added one, the in-flight safety system. So I already done the implementation of the case study. And the last one is the ATM system. This one is also already done. These are the evaluation metrics that I use for my research. For my MBTCG approach, the metrics are mutation analysis, code coverage, and test suite size. And here you can see the justification why I use these metrics. And for my prioritization, as I said earlier, I use the APFDC, and here is the justification why I use this metric. And then this one already explained in my first presentation, some introduction about mutation score, how you are to calculate the mutation score. This one is new, or this new add. How to calculate the FPFDC. So I think I will not explain in detail this one. This is the equation. So an interesting thing is that here I want to point out is when both the test cost and fault severity are identical. So this formula will reduce to the formula of the for FPFD, because when cost and fault severity is the same, it's like we use the typical FPFD. And then these are the tools that I use in my research. First one is Test Optimal. This is an MBT tool, IDE. I use this to perform the MBT part, such as the model construction, automated test generation, and automated test execution. And this is the justification why I use this tool. And also other tools is Mujava. It's used to seek faults into the system under test, to measure the quality of the generated test suit using the mutation score metric. This is the justification for using the tool. And lastly, I use ECLMR to get the code coverage, to calculate the code coverage metric. Here I did some comparison with other similar MBT tools. So this already explained in my first presentation. Here are the comparison for the mutation testing tools. Okay, so next for chapter 4, my proposed generation and prioritization approach. So here also no major comment. I think some minor comment. Then the new progress is I complete the fundamentals of the proposed MBTCP approach. So the framework is not done yet for the for the prioritization approach, but the fundamentals is ready so that I can implement the approach. So this one is same with my previous presentation. This is the framework for my generation approach. So I skip this one. So previously I showed the different types of automated test data generation techniques. So here I showed the justification why I choose the combinatorial testing type. So here for my proposed prioritization approach. So here are the main idea. So here I show some screenshot of the implementation. So I implement this prioritization approach in Eclipse to make it easier to implement, because if manually it's very a long time to implement. So I automate the implementation in the Eclipse. Next chapter is chapter 5, my preliminary findings. So there's one comment from the examiners that the experiment setting needs further detail and justification. So to address that, I added a section explaining the independent and dependent variables in more details. And also currently, my current progress is I'm working on implementing the proposed generation and prioritization approach for the remaining 2 case studies. So here is the structure of the preliminary finding. So here the one that I add for the examiner comment. So basically there will be like 2 experiments. First one for the generation and one for the prioritization. So for the generation, the independent variable will be the generated test data sequence, okay, with 2 treatments. First is the test data sequence from the proposed approach, and then the test data sequence from the conventional model-based TCG. And then using that 2 treatments, I want to see the dependent variables, if how they change the dependent variables. So how they change the mutation score, the code coverage, the test suit size. And then for the prioritization, also one independent variable, the resulting prioritized test suit with 2 treatments. the prioritized test suite from the proposed approach and the prioritized test suite from the random-based approach. So when applying these two treatments to the dependent variables, the APFDC, how they change the APFDC value. Okay, so this is from the previous presentation, still the same, how I seek for. This one I also skip. This one is how the illustration of how I apply my generation technique. So here is quite technical, so I will not explain. Here are the result and discussion. This is for the lift system case study. As I said earlier, I'm still doing implementing the generation and prioritization for the remaining two case studies. So I don't have I have some of the data, but I don't have all of them yet. So this is from the previous one data. You can see here that you can see one of the observation is that the mutation score from my proposed approach 77.94, and from the conventional MBTCG is 71.32. So you can see here that the proposed approach is effective in detecting fault. And for the model-based test case prioritization, this is the I calculate the APFDC for the two independent variables. First the random based, and second is from my proposed approach. So this is the ordering 100. Actually, above here there is more ordering from ordering 1 until ordering 100. So because this is a random based approach, it will be a non-deterministic approach. So I take the first 100 generated test suite and take the average. Because it is non-deterministic, the result will not be the same for the same input. Okay, so you can see here that the highest APFD for the random base is 0.9938, chance 1% chance, meaning that only once it will appear, and the lowest APFD is 9776, also same chance, and the average APFDC that we want to see for the random base is 9884. And for the proposed approach, you can see the average APFD is higher than the random base. So you can see an improvement there. So that is what this is for also for the lift system. So for the conclusions, I conclude based on my research objectives. So from my first progress presentation, I had done only the first objective, and the remaining two is not started yet. And right now for my second progress presentation, I had done the first and the second. I had done proposing the generation approach and prioritization approach. And now currently work in progress is to evaluate the effectiveness, efficiency of my approach for the remaining two case studies, the ATM and the in-flight safety. So that is all from me. Okay, thank you for listening.
Assalamualaikum, Luqman, Dr. Dayang.
Salam, Prof.
Can you hear me? Yeah. All right. My question is, you are doing test case generation. You are using combinatorial testing, right?
Yes.
And then you also doing test case prioritization. All right. When we're talking about test case prioritization, usually we are referring it to regression testing. Okay, meaning that there will be some changes due to the enhancement or maintenance of the software. Then we need to do the regression. Okay, from your literature review and from your research design, how can you view the use of test case generation together with the test case prioritization, which is the TCP, within the scope of regression? Meaning that if there are any changes, do we need to regenerate the test cases again, or we only generate it once and then the rest of the regression happen using the prioritization? How does it goes? How you design it in your research, and how other researcher look at their way of doing it in the literature review?
So actually, I am focusing on. I am not focusing on the regression testing. I'm focusing on the more on the initial phase of testing, seems like the general testing. So I did not focus on the here. I did not focus on the regression testing because why? I want to prioritize the. I want to prioritize the test case after they are generated from my proposed generation approach. And about the modification, if it depends if the modification in the system is significant enough, then there will be new test case that will need to be regenerated. But I did, for the prioritization, I did not focus on the regression testing. I did not use any information from the previous iteration of execution. So I just used the information from the current execution.
Okay,
So
my recommendation is for Luqman to have a look at any existing researcher approach currently which consider test case prioritization without considering the regression nature of the research or of the software. Because usually when we say something about prioritization, selection, or minimization, usually we are, especially prioritization, usually we refer it to the regression testing. If this is not the case in your research design, try to have a look of existing work who already, which consider this as an initial generation and prioritization in order to get the best test cases without considering the regression. Okay, because mostly when we're talking about prioritization, most researcher would assume it is a regression. Okay. All right.
yes, I also found that most prioritization they want to address for regression testing.
Yeah, because I went through a viva where there is an examiner who cannot accept the statement saying that you are doing prioritization, you are not doing regression. They will automatically link that when you're talking about regression, when you're talking about prioritization, it will automatically doing regression testing. But there is a possibility examiner have that point of view. So to be safe, you have a look of the number of researcher who considering test case generation and prioritization, which not consider regression in their scope.
Thank you, Prof.
Mr. Luqman, I have one. So, what do you use to represent cost in your cost-cognizant prioritization approach?
For the cost representation for my prioritization test case, so you can see here that the existing studies use. You can see here that the existing study use, most of them use test execution time because most of them want to focus on regression testing, so they have that test execution time. So because I don't focus on regression testing, so I will need to assume that I don't have that test execution time data. So because of that, to represent cost, I use test case length. For example, here this is for example a test case. So the test length will be how many states and transitions traversed by that test case. So here, for example, 1, 2, 3, 4, 5. So that will be the length of the test case. So why I use this? Because generally this more state and more transition to base drivers will be will equal to more time to execute tests. And I also already test this, investigate about this. Here you can see that I investigate the total state and transition for 55. Okay, so this is the length, and then this is the number of tests that have that length. So the average execution time is 7 seconds. So for the shorter length, shorter time. Okay. So this you can see here that the test case length can represent test cost and test execution time. So that is my answer. So I use the test case length to represent the test cost.
Thank you everyone for the question, also comment. Now we are approaching the end of the colloquium today. Lastly, thank you everyone also for your participation. Have a great day. Stay safe and see you in the next colloquium. Thank you and Assalamualaikum.